everybody. Thanks a lot for coming to my talk. My name is Trevor Conn. The title today is Decomposing the Monolith, but as you can see, I have 4 Ds and not 3. The reason for that is because the architecture that we decided to roll with in this project was a distributed domain-driven design architecture. I'll get into a little bit about what that means in the talk. And then the whole idea of this is I want you to learn from our mistakes. We failed so you don't have to. I hope there's some good takeaways for you in here. So I'm a senior principal software developer. I work at Dell, and I recently moved to a brand new IoT division within Dell. Currently, my main responsibilities are for a new microservice platform called EdgeX Foundry, which you can find on GitHub. I interest you to check it out if that's of interest to you. So let me give you a little context for what it is that we were trying to build. The teams that I had oversight for were in charge of building an online configuration tool for commercial customers. And these commercial customers would buy a whole lot of hardware, networking products, etc. And so the service-oriented environment in which our application participated was very rich. Lots and lots of services everywhere, mostly communicating through WCF, a little bit of REST. And all of these services were massive, really large monoliths talking to one another. We had to interface with services that would give us things like the product catalog, configuration rules, and validation about how a product could be configured, including how they can be configured in relation to one another, and then also pricing. It started out even within our org as something of an SOA where we separated some business level services from presentation services, but we ended up compressing all of that into a single deployable unit for performance reasons, even though we preserved the contract between these two layers, deploying it singly, because in some cases we still wanted to use the underlying service tier as a service. We did use CQRS. We called the configuration that a customer would be working with a solution. And within that solution, you could have hundreds of products. So these things could get really, really big. And in order to display that information on the web page, you wouldn't want to go and run through a relational database to build that document in real time. So we did have CQRS using nService bus in order to establish a read model that was pulled out of Elasticsearch. At the time of this effort, the application was about 5 to 6 years old, so it was starting to show some of its age. And the environment that we were deploying to was all IIS-7 running on VMs, nothing like containers. And in fact, the application had dependencies on specific file resources, especially for things like content translation, even some of the display style sheets and things like that. That would all be replicated through a distributed file system. So this is kind of the primary configuration screen. The reason that we started down the path of re-architecting our application was because we had a new product that we needed to sell. And the configuration experience wouldn't support some of the capabilities of this new product. And so what we wanted to do was provide a configuration experience for this one product and do it in a way that could then grow over time to replace the old system. So our scope was intended to be very narrow at first. But as you can see here, you have basically a header at the top, the product list on the left, some configuration options on the right that scrolls way, way down the page, and then pricing in the upper right-hand corner. This is all painted the first time the page is loaded. It's all painted at once, and then there are either jQuery or React widgets on the page that will do partial callbacks and things like that. So in trying to approach this re-architecture, we had been reading a lot about domain-driven design, and we said, okay, let's look at our existing subdomain and try to conceptualize it from a DDD point of view. And our first round of analysis was not good because we wound up thinking that we only had one aggregate. And that aggregate had to be transactionally responsible for everything in the system. Nothing could be done, for example, with solution items there at the bottom. That's a particular kind of product. That's a server, for example. Nothing could be done in terms of configuring that thing unless we went through the solution aggregate route. And so there was an enormous amount of complexity that we originally were planning for in this effort. And then we asked ourselves, well, we've got this other stuff like shipping, customer info, quoting, which happens downstream from us. How did that even get into our application? Because that's not even our subdomain. What are we going to do about that stuff? And so after thinking about this and kind of wrestling with the problem, we decided to go back to the user experience and say, well, how can we think about the experience we're trying to present in terms of allowing us to sort of decouple this? And here's what we came up with. And I made an adjustment to this slide just this morning, thanks to Eric Evans, because I realized that we were not using the term aggregate correctly. I think that probably these are better served being termed bounded contexts, because what we wound up with was a service for each one of these, even though those services really only had one aggregate root. And so we sort of conflated those two terms and started talking about aggregates as if they were services. We made a mistake there. So I went ahead and I fixed this slide because I think this is closer to the intent of what we should have been doing, how we should have been talking about things. In any case, as I mentioned on the screen before, we had a solution header, which is the general details of the solution, rules and information about the state of configuration, products that were part of the solution, and then also pricing. And we would initialize all of these at once so that there was a common key for all of them to listen for each other's events and know that's mine, I need to react to it. So just to give you a visual, this is kind of what I'm talking about. And what we wanted was, on the UI, we wanted to have sort of a wrapper that would orchestrate the different individual widgets that aligned vertically through the stack with the bounded context that they were responsible for. So in this case, let's say down here in the product box, I wanted to change that quantity. If the user changed that quantity, then that would also affect the pricing in the upper right-hand corner. Down here in configuration, if I changed some option, maybe I want more RAM or I want more hard drives, then that should also change the unit price over in the product box as well as the pricing in the upper right-hand corner. So it didn't have to be painted all at once. Like previously, when the user took action on a page, they had to wait. And so what we were trying to say is, okay, go ahead and take that action, because effectively what we're doing is we're sending a command, in a series of commands to our aggregates on the back end, and then they're pumping out events which are going to get materialized in a view and sent back to the UI. So it was okay if things didn't paint quite at the same time. We were expecting that behavior. So again, just to go through the list, we were envisioning a composite UI that would aggregate the behaviors of these different bounded context-oriented widgets. The actions taken through those widgets would send commands through a service API. We were implementing our underlying aggregates as actors using Microsoft Orleans. And then when, let's say, for example, add product comes in, then I want to assuming that that command is valid, I had to do some checks on that. Assuming the command is valid, then the aggregate is going to emit a product aggregate event. A product added event. That will then go into the event stream, which we were using Kafka for. So then we have subscribers that are building the view that will eventually be sent to the page. And so they're reading out of their particular partition in Kafka and doing what they need to do in order to display the event, and then sending a notification to the UI. We were using SignalR for this to say, hey, your event's ready. And so then there would be a callback, and we would pull that particular fragment to render it on the screen. And it just happens in a loop as the user is participating with the application. So if you're not familiar with implementing domain-driven design by Von Vernon, highly recommend it. I personally think it's one of the best books out there that combines the theory and the implementation of how to do all this stuff. And a lot of the ideas are in Appendix A of that book. So I highly recommend that book if you don't have it. So in a large corporation, when you have reproductizing, re-architecting, some new way of doing things, you have to give it a name. So we wanted to name this thing. And so we sort of solicited suggestions for what should we call this from the teams. And then we picked what we thought were maybe, the 8 to 10 best ones. And then we said, okay, vote on these. And the one that was chosen was Phoenix. Does this strike anyone as being ironic? I mean, it sounds good, right? The new rising from the ashes of the old to soar high into the sky of prosperity. But has anybody heard of this book? I had not heard of this book at the time that we named our project. And had I heard of this book, I would not have allowed us to call it Phoenix. Because this is exactly what happened to us. So if you're not familiar with this book, there's basically an automotive parts company that's trying to re-architect its e-commerce pipeline in order to keep up with its competitors. And that project is just an absolute boondoggle, not only from a development perspective, from a testing perspective, from a delivery and a support perspective, every way that you can think of, it's over budget and isn't being delivered. And it goes on for like 3 years. Eventually, that product is superseded by another project where they basically just decide to abandon Phoenix and streamline their delivery processes in such a way that they can replace that effort and eventually reach the company's goals. So again, another highly recommended book if you haven't read it. So now I'm going to get into a little bit of the issues that I have identified in retrospect that I think that we encountered. So we talk a lot in domain-driven design about bringing technology and business together, and I absolutely believe that that should happen. However, in our case, it did not happen. And the reason it didn't happen was because this was driven by a subset of our technologists, including myself, who really wanted to champion DDD as a software development practice. Our product owners and our business partners knew absolutely nothing about DDD, but we figured, you know what, we've got to carry the torch. We've got to somehow show them the value of this methodology and this discipline. So we decided that we would just go ahead and start working on this as an R&D project with some budget that was left over from another project, because in enterprise organizations, you always over-budget, overestimate how much something's going to cost so that you can bury the R&D. So that's what we were doing. And we wanted, for our own selfish reasons, to modernize the technology stack, to sort of raise the culture that we were working in. Like I said, the application was really showing its age. It was really hard to support, hard to debug, hard to extend. There's got to be a better way. And we were just getting tired of coming to work every day. So we wanted something interesting to work on. And of course, geeks like to play with cool stuff. The second sort of thorny issue that we had was the enterprise architecture team. So in a large organization, you have enterprise architects. What do? It seems like sometimes they just exist to say no. They will tell you that their responsibility is to ensure the stability of the platform across the enterprise. And maybe that's true on some level, but they really don't have any of the delivery pressure that people like us do. And so they remain very abstract and aloof, kind of hard to contact. And we wanted to involve them. We really did, because we thought of this as being the first step in a transformative initiative that would be a benefit to the whole company. But they didn't have time. So we said, well, the hell with it. We're gonna start doing this anyway. So about a month in, we went to them and they said, hey, okay, we've kind of got an idea of how we're going to sequence this thing. We want to present that to you and see if we can get any feedback, see if you're on board. And they just plain didn't have time to talk to us. So we said, okay, we're going to continue. So about the third month in, we were really starting to get an idea of what this was going to take. And we had chosen some software platforms on which to build our application. Our techniques and our strategies were really starting to take fruit. We were starting to extend this out into other feature teams. It wasn't just like one feature team with the architects focused on that. We were now starting to say, okay, this is going to, we're going to schedule the backlogs for these teams. We would like to get your buy-in. And they said, well, you know, it sounds kind of interesting what you guys are doing, but you can't use that platform. The platform that we were targeting at the time was Service Fabric. And we were like, well, that's just them telling us that, you know. Again, if we can demonstrate the value of this, they're going to be so enthused by what we've done that they're going to come on board. We're going to convince them. So a couple more months go by. We've made some really good progress now. Around this time, we had a demo with some of our product owners and our business stakeholders. And one of the things we were able to do with the new application was provide a collaborative configuration experience. Never before had more than one user been able to configure one of these solutions. And it really shortened the sales cycle, because now you didn't have to take the user's feedback through some kind of email or phone conversation, put it into configuration, email that to them. Is this what you want? The back and forth. You didn't have to do that anymore. You could actually have more than one person on the screen seeing things change in real time. And everybody went, that's awesome. So now we had business buy-in. Well, the architects said to us, okay, that's fantastic, but we told you, you can't use Service Fabric. And around this time, there had been some percolation up to really senior levels of management who were kind of getting interested in what we were doing. And they came to us and they said, you cannot use Service Fabric. You have to use Cloud Foundry. So that meant that we had a whole implementation reset. And we lost a lot of credibility because of that, because now everything that we had just demoed, we had to refigure out how to build it. And all of our timelines shifted to the right. And people were like, didn't you get sign off for this? Didn't you get approval for this? So that was a challenge. And I don't want to make it sound like Cloud Foundry isn't a good platform, because it absolutely is. It just has different capabilities of Service Fabric, and we had really sort of bought our way into the Service Fabric model of doing things. So Eric Evans touched on this a little bit last night. When I look back in hindsight at some of the things that we were asking our team members to take on, it was completely an unreasonable ask. You definitely will always have folks who are software developers who stay very current, who spend a lot of time looking at how new techniques, new practices, new technologies work. But not everybody's like that. And not everybody has the professional experience to really think about how to design and deliver a distributed application. So some of the new conceptual things we were asking people to understand was DDD, which, we're all here probably years into this trying to understand it ourselves. It's not a thin topic. And then as well as microservice patterns and practices, what is the actor model? And then event sourcing. How does something like an event source application work? These were all new things to many of our development staff. Beyond the conceptual layer, the new technologies that we had to have people work with were things like Service Fabric. And then once that got kicked out of the way, Cloud Foundry, Orleans, .NET Core. At this particular time, we had a lot of challenges with legacy .NET code that we wanted to use that we couldn't reference in .NET Core. And so now we were like, oh, we got to rebuild all this stuff. We've got some third-party library that won't compile in .NET Core. So there were challenges that we were inviting for ourselves there. And you might think, well, just send them to a conference. Bring someone in-house and do some training. And believe me, I asked for that, but I was told there was no budget. And we as architects, we play around with this kind of stuff a lot. We do it in a sandbox. We prove out concepts. We do spikes, demonstrate things, maybe give brown bags talks at work. But none of us had ever really built anything like this before. The culture of an enterprise that hasn't really seen itself as a software company is not a fail-fast culture. They expect you to do something once and to do it right. And so that's what we were doing. We were effectively learning with production code. So obviously somebody's got to do the work, and you have to come up with a plan for how you're going to deliver all these pieces. And so we had 3 feature teams, and we had several different attempts at trying to figure out how we could map the team resources onto the work that needed to be done. Technological alignment, functional alignment, and hybrid. This is the first thing we tried, technological alignment. So across the horizontal layers, you can see that we have a team for actors, a team for the API and the asynchronous view projections, and then the UI itself. What this allows is that a given team can restrict the amount of technological overhead it needs to absorb while maintaining a full visibility to the business context that they need to solve. The pushback that I got for this was that, okay, well, Team C has some developers that don't really want to work on UI. They would rather do actors, or they would rather do microservices. And they feel like they're going to get stuck there forever. And that was never the case. That was a misconception. And I emphatically said over and over again that it's okay if a member of Team C doesn't want to work on UI. That's where they are now. Maybe they'll be there for 6 months. But if they want to work on actors, there's nothing stopping them from issuing pull requests to the actor team's repo. And over time, as you build reputation, when an opening comes up on Team A, there's your in, right? There is no reason that someone has to get stuck working on a team for years and years at any layer of the stack. None. Go where your interests take you, show that you're interested, build a reputation with that team, and they'll be glad to have you. But I could never overcome that objection. So because of that, we went to a functional alignment. And the functional alignment required every team. For one thing, you can see there's more than 3 aggregates or bounded contexts. So that meant that one team had to pick up 2 of them. This means that every team has to have the full range of technical intake. They got to ramp up on all this stuff. But they've now only got visibility to a particular sliver of the business context. And this is a recipe for misunderstanding, where the person that's working on product thinks that configuration needs something from product that configuration doesn't actually need, or configuration is misunderstanding the message the product is going to send, or there needs to be some kind of change, and now the feature has to be aligned across all these teams to deliver at the end of the sprint, and Team B is falling behind, so now Team C and Team A are also behind, and it was just a massive churn, especially when we started to get into NuGet dependencies, because these teams at different layers were sharing NuGets. Let's say the product aggregate has to publish an event. That event is represented in some NuGet that the configuration aggregate has to import in order to deserialize the message. And if those properties aren't added in a timely fashion so that they can be tested, we just ran into all kinds of dependency and delivery issues, as well as conceptual misunderstanding of what each team was supposed to be doing relative to the overall problem we were trying to solve. And then, as I said on my previous slide, the third thing that we tried was a hybrid. And that was ultimately the most long-lived strategy, but its swim lanes were ridiculous, so I'm not even going to confuse you with that. Testing was a challenge because up to this point, the only real testing that we had done was UI testing. The mechanism was Selenium scripts that would run against the UI, trigger these inputs, look for elements in the DOM to make sure that certain results were achieved. It's all going to happen in real time. There wasn't really a whole lot of benchmarking. You could measure how long a response would come back in, but as to whether or not you gave that a pass or a fail, it was inconsistent. So our established practice is just to look at the UI. The unit test methodology, in addition, isn't really good. The coverage wasn't extensive. Sometimes they were more integration tests than unit tests. So what we came to the test team with was, hey guys, we're going to need to rethink how we do our testing for this application, and we're going to have to test at each level of the technology stack. I want to test being able to send a command to an actor and make sure the right event comes out. For a view projection, I want to make sure that given a certain state, when this event comes in, I'm able to get a certain document. And then from the UI, the same thing. I need to be able to know that when I receive a notification, I can get the fragment I need from the view generator, put it on the screen, and then you need to test the whole thing end to end. So now there's basically 4 levels of testing that have to be done. So in addition to the methodology challenges, and I need to give the testers props actually, because they really applied themselves to trying to help us to solve this problem. They were really enthusiastic through the whole project, and I think a lot of them were really challenged by what we were trying to do, and so I give them props for their positive influence. The organization, though, they were not integrated with the development teams. While they sat on the same row with the development teams, they reported to a completely different management structure, and so their priorities were not always our priorities. If there was a problem in production, or if a bug was found, if a team upstream was doing a rollout, and that rollout affected some behavior in our application, they would get called away to go test that. So their attention was divided, and so it made it difficult sometimes for us to get the tests that we actually need. For example, in a sprint, for whatever reason, in a sprint, the developers were not required to write these integration tests. They were relying on the testers to do it. And so what that meant was that the developer could get a pass by putting their code in, testing it themselves, however they would do that, and then the next sprint, the tester would write the actual test. So if there was a delay in getting that test because of some production issue that people were working on, it would start to creep out and farther. Features are coming in faster than they're getting tested, and so there was a real gap. This all sounds very manual, and it is, and that's indicative by the fact that none of our testing was really integrated into our CI pipeline. We had some metrics that were captured around pass and fail, but nothing that would really give us any kind of real benchmark about how the whole thing was working. The other thing, too, is that the environments that we were deploying into, and this is historically as well as with the new project, you would deploy code into a staging environment, and that staging environment has every service in the entire e-commerce ecosystem deployed into it. And they all have to be working flawlessly for your application to work. And if it's not working flawlessly, you have to go contact that team, who may be on the other side of the planet, who may not answer the first email that you send them. And then you have to get one of their PMs involved, and it's just a political nightmare. So none of this is conducive to rapid development, as you can see. So in traditional enterprises, you frequently have teams called IT and release management. And you can take everything right to that last mile and get completely blocked at this point. So in traditional enterprise IT, these are the folks who are responsible for your hardware, your networking, your VMs. At the time that we were getting ready to deploy this into production, we also had this new kid on the block, Cloud Foundry, that was making all these waves, because that was managed by a completely separate team than the regular VMs that we had. And so these two teams were fighting, and they didn't see eye to eye. So now we've got an application that has to be coordinated in these two completely different DevOps pipelines, and that was a challenge. With the VM environments, you go through a process of provisioning. You give them a specification for what it is that you want. You have to justify why you're making the specification, and that paradoxically requires an awful lot of knowledge about how your application is going to function in production before it's in production yet. So frequently what people do is they over-provision. So you might think, well, I'm probably only going to need 8 boxes, but I'm going to ask for 16, just in case. And then, if your application doesn't go out, it might take you six months to get those boxes. And if your application doesn't go out, you don't tell anybody, because now I've got these boxes, and I can do something with these boxes. Then I don't have to go through the provisioning exercise. And then when you eventually do deploy something to them, the names don't make any sense with regard to the application that they're now running. And it's crazy. And VMs can live for a really long time. Like some of them have been out there for years. And because it's not like a standardized build up, tear down, containerized deployment type of model, the configurations on these things drift over time. And so, people get in there and they do OS patches, they do troubleshooting, they forget to roll something out. And so, in your 16 machines, now 4 of them are doing something weird and you can't figure it out when you look at your traffic patterns to say, well, why is that one taking long? Or why is that one failing? And it seems to be a certain regular percentage, but, the load balancer's hitting it, spreading it to these boxes with the irregularities. It's crazy. And the devs had zero access to these VMs. We'd have to go through trouble tickets and things like that. Now, Cloud Foundry comes along and says, okay, we've got this new team in process. We're going to use build up, tear down, container type deployments. Monitoring of all your services is built in. Scaling of your services is built in. And that's great. But you know what? The old team wants to be involved. The old team wants to be the one that clicks the button in order to get something out to the farm. And then this is where we get into release management. So if IT manages the infrastructure, release management is in charge of making sure that nothing goes out that's unexpected. And in a big enterprise model, they like to, maybe do 4 releases a year, once a quarter, right? Maybe more often than that if there's a really severe bug. So anyway, these releases are determined well in advance. When you release, you frequently have numerous dependencies in the ecosystem that have to release at the same time. So we get on these release trains where if you go from service A to service G, service A is going, now service B is going. Oh, they found a bug in service C. We're all on this call. They found a bug. How long do you think it's going to take to fix? They don't know. Okay, well, let's come back in 3 hours. Is it fixed yet? No. Let's come back in 3 hours. And so on. And the release train can, it's scheduled for maybe 2 days, but it could take a whole week because of these delays. So there's no way that traditional release management is prepared for being able to deploy a service real quickly with small changes throughout the day, being able to monitor that. In addition, because of the the reasonably quarterly release cycle, we only had 4 staging environments, and those were basically aligned to the quarterly release cycles. Now, because we were kind of skunkworksing this thing, we only put our VMs in one of them. So I don't know why we did that, because assuming it went to prod, we would have had to scramble to get VMs in environments 2, 3, and 4. The other reason, too, was there was a security limitation because the other party that was providing us product information, we had to make a direct network connection, and it took us like 3 months to get that set up. So in order to go through these other environments, it was going to be a long and complicated process. So just to get started, we said just do it in one of them. But obviously, that was going to cause a long-term problem if we were successful. So we were using Octopus, which is great because a lot of the teams weren't. But we didn't have any of the maturity built in place, like the blue-green deployments, no testing integration. Release management would constrain us to say, well, you can only push to these boxes from noon to 4 p.m. We're like, why? But there was no way around that. And they were insistent on, when it went to prod, being the ones to click the button. So we couldn't do that. All right. I'm going to take a breath here. All right, so the obvious question. You're going through this whole list of problems. How is it in the world that you ever thought this was going to work? Why couldn't you see this up front? And the only thing I can tell you is that I was completely blind to anything outside of the problem of building the software. And I was so convinced in the righteousness of what we were trying to do and the benefits that it was going to provide, that we had to be the first to drive the spike to show the benefit to the rest of the organization. And unfortunately, it doesn't really work that way. One of the things that I would have appreciated, and I think this is an important role that management has to play, is to harness the enthusiasm of people like myself and really evaluate whether or not the plan is sound, and then compare that against the organizational intelligence that someone on the management side has. Be able to say, first of all, if it's a terrible plan, I'll tell you that right up front. But if it's a good plan, temper the expectations by saying, here are some of the roadblocks that we're going to have to overcome. It may not be feasible for us to do this either on the timeline that you're thinking of or at all. And while I would have resented that feedback to start with, in hindsight, it would have been the best thing for me and my fellow architects at the time. But technical managers can also get carried away by the new hotness. They've got this downward pressure because they want to keep good talent. They want to elevate everyone to a higher standard of work and quality. They want to make sure that people enjoy their jobs. And they want to make sure that the culture is vibrant. So new technologies will do that because people like to solve interesting problems. Then, flip side, the upward pressure is that, well, the promise behind these new technologies and these new architectures is faster delivery, more features, shorten the sales cycle, more revenue. So that's what they're messaging upward. So they're also caught in between these two directives that sometimes they can buy into. The other thing, too, is that in a skunkworks project, you want to really be careful about plausible deniability because depending on the size and the character of your organization, if something goes wrong, if your project goes into prod and it falls flat on its face, then you'll be the one to take the fall. They will have said that you have gone rogue, and then HR will come after you, and it won't be pleasant. You're also the one that's taking all the risks because you have no cover in this kind of organization. If you're the one that's really steering this and it goes out there and doesn't work, you're the one that is taking the risks. But if it works, then you'll get some rewards, but the people above you are going to get the real rewards. So one of the things that I wish, it signaled a lack of commitment to the effort when my manager wasn't willing to help me clear some of these obstacles. He had the relationships to at least be able to talk to some of the other members of the enterprise to find out whether or not, from the outset, something like this would have even worked. We as technologists, we sometimes get buried in our silo, and we know a lot of people on the technical teams, but we don't necessarily know people in other orgs. And those relationships are going to be really, really important for you to effect any kind of change within the enterprise. And then also, always be on the lookout for parallel tracks to a deliverable. So if you're working on a project and you hear about, hey, that team's working on the same thing I'm working on, but they're doing something different, that's a red flag. All right, so let's wrap it up. When you're thinking about bringing in a new architecture, it's not just about software. You have to think about how you're going to deliver the application, how you're going to support it, how are you going to test it, how are you going to measure what it's doing. Is the organization and the team members that you work with, are they at a certain point where they can start building something like this? If not, can you get the resources? I don't just mean people resources, I mean like training resources. Can you get the resources that you need to support your transformation? And then also, what's the business value? I mean, in our case, we did demonstrate business value eventually. We got the product owners and the stakeholders on board, but then, like I said, when we had that implementation reset, it chewed all that up. It really made us lose a lot of credibility. So covering all of this in your traditional enterprise that, again, doesn't think of itself as a software company is going to be slow. It's going to require personal relationships throughout the company. So definitely work on cultivating that. Just like the talk that Jessica was talking about, where relationships are important. Synergistic skill sets can contribute to a value that's greater than the individual sum of the parts. And it's going to require long hours. I mean, trying to do all of this, staying current with the 3 teams that we had working on this, trying to keep the designs fresh, making sure I could prove a concept before handing it over, working through the backlog grooming, working through the political processes of all the stuff that I just went through, long hours. And then also pay attention to the signals that your software's operating context is giving you. And by that I mean observe the nature of the company that you work in. Do they even think that there is something that needs to change about their main product? Are they satisfied with it? Is it profitable? Is it driving revenue? If so, you may just be working on a pet project. You may not be working on something that is going to ultimately be a real driver for transforming your enterprise. It could be that the architecture that you have now is the one that is best suited for your environment. And you have to objectively evaluate that. You can't get carried away passionately by your convictions because you're excited when coming back from a conference. And if you feel like, hey, I need to build this kind of application, or I just don't want to write software anymore, then maybe you need to find another job. You always need to keep that in the back of your mind. So I hope this has been somewhat helpful for you. I want everyone in this room to be successful in the projects that you're working on. I want you to feel fulfilled and happy about the work that you do every day. I don't think I really have time to take questions, but I'm here, available. I'm willing to talk to anybody if you want to come up to me later. Thanks. Enjoy the rest of your conference.